Hello students, welcome to class. In my last class, I talked about the particulate nature of matter. Today, I will be continuing with the particulate nature of matter. So by the end of this lesson, you should be able to give the definition of atomic number, mass number, isotopy, and also calculate questions involving the relative atomic masses of isotopic elements.
The atomic number has a symbol Z. This number tells you how many protons are in one atom of an element. The number is always the same for all atoms of a particular element. Atoms of different elements have a different atomic number, meaning they have a different number of protons. For example, an atom of hydrogen has an atomic number of 1 because it has 1 proton. But an atom of oxygen has an atomic number of 8 because it has 8 protons. The next number we look at is the mass number. The mass number has a symbol A. The mass number tells you how many protons and neutrons are in one atom of an element. We need to remember that protons and neutrons each have a relative mass of 1, and that electrons are so small that their mass does not need to be considered in the mass number of an atom. So if we know the mass number of an element, and we know the atomic number, we can calculate the number of neutrons in an atom of a particular element. So the mass number equals the atomic number plus the number of neutrons. The atomic number is just the number of protons in an atom. Therefore, mass number equals protons plus neutrons. So if we take oxygen, oxygen has a mass number of 16 and has 8 protons. But how many neutrons does it have? Remember, mass number equals protons plus neutrons. We can rearrange this to show that neutrons equals mass number minus protons. Neutrons equals 16 minus 8 equals 8. Oxygen therefore has 8 neutrons. Let's take another example. Lithium has a mass number of 7 and has 3 protons. How many neutrons does it have? Mass number equals protons plus neutrons. We can rearrange this to show that neutrons equals mass number minus protons. Neutrons equals 7 minus 3 equals 4. Lithium therefore has 4 neutrons. So the atomic number is the number of protons in an atom, and the mass number is the number of protons and neutrons in an atom.
Welcome back from that video. It is question time. How many neutrons are there in the nucleus of an atom of an element with mass number of 23 and atomic number of 11? You recall that the mass number of an element is the sum of the numbers of protons and that of what? Neutrons. So therefore, number of neutrons will be equal to mass number minus atomic number. And from the question, the mass number is 23, while the atomic number is 11. Therefore, the neutron number will be equal to 12. If that was your answer, you were correct. Next, we'll be talking about isotopy. Isotopy is a phenomenon whereby atoms of an element exhibit different mass numbers but have the same atomic number. This is due to the differences in the number of neutrons that are present in these atoms. Note that atoms of an element that exhibit
the same atomic number but different mass numbers are called isotopes. Examples of elements that exhibit isotopy include hydrogen, oxygen, carbon, chlorine, etc. So you take note of these examples.
Calculate the relative atomic mass of an element from its isotopic abundances. If we consider carbon, its relative atomic mass is very close to 12 atomic mass units. This is because, in nature, 99 atoms out of 100 atoms of a carbon sample are carbon-12 isotopes. Another way of saying this is that carbon-12 has a 99% isotopic abundance. However, not all relative atomic masses of elements are weighted in this way. Chlorine, for instance, exists as two isotopes, chlorine-35 and chlorine-37. How many protons and neutrons do you think each chlorine isotope has? Remember, the mass number for an isotope is equal to the number of protons it has plus the number of neutrons. Pause and select from one of the following options. Use the chemical symbols to help you work this out. Both chlorine-35 and chlorine-37 have 17 protons, but the chlorine-35 isotope has 18 neutrons, whereas the chlorine-37 isotope has 20 neutrons. The answer was A. Did you get it right? In nature, out of 100 atoms of chlorine sample, 75 of those atoms are chlorine-35 isotopes, and 25 of those atoms are chlorine-37 isotopes. For you to be able to work out the relative atomic mass for chlorine, you have to multiply the mass number of the isotopes with its abundance, percentage, and add these products together. This gives the total mass number of the isotopes. Using this data, can you calculate the total mass of chlorine isotopes using their abundance and mass numbers? Pause, think, choose, and continue when you're ready. The answer is B. You have to multiply a 75% abundance of the chlorine-35 isotope by its mass number 35. You then have to multiply a 25% abundance of the chlorine isotope by its mass number 37. When added together, this gives a total of 3,550. The final step in calculating the relative atomic mass is to divide your answer by 100. This is because the abundances are given as percentages. This means chlorine has a relative atomic mass of 35.5. Here's a challenge. From the following data, calculate the relative atomic mass of uranium. Pause and continue when ready. Make sure you write your working out down as you do the calculation. The correct answer and working out is displayed on the screen. Remember, you then have to divide this value by 100. That gave you 237.99. Did you get it right? In summary, the relative atomic mass is the average weighted mass for the isotopes of a particular element. To calculate this, you need to multiply the relative abundances by the mass number of the isotope, add these products together for each isotope, and then divide the total by 100. And that's how you calculate the relative atomic mass of any element from its isotopes in the periodic table.